Before diving into any details, a quick note, the purchase link for the fuel injection pump is available down in the description. If this part matches the engine or machinery needs, the link will direct to where it can be acquired. This session covers an in-depth look at a fuel injection pump designed to fit Perkins 1004.4D diesel engines, a 4-cylinder power unit widely used in excavators and similar heavy-duty equipment. The goal is to thoroughly analyze this aftermarket pump's build quality, operational performance, installation process, and long-term reliability to assess if it serves as a trustworthy replacement. To begin, it is essential to understand the role of the fuel injection pump within diesel engines. This component's function is to deliver the correct quantity of diesel fuel at the right pressure and precise timing into the combustion chambers. Any inconsistency in fuel delivery can result in inefficient combustion, causing poor engine responsiveness, increased emissions, excessive smoke, or in some cases, severe engine damage. Thus, selecting a pump that meets or exceeds OEM standards is vital for engine health. First, a physical inspection is necessary. The pump's external structure reveals much about its quality. The casing typically consists of a robust metal alloy, often cast and machined to exact specifications. The mounting flanges, bolt holes, and port locations must correspond exactly to those of the Perkins 1004.4D engine. This ensures seamless installation without modification. Upon examination, the pump in question demonstrates precise machining and proper alignment of all external components. The bolt hole spacing, flange flatness, and inlet/outlet port geometry appear well crafted and consistent with the Perkins OEM blueprint. The metal surfaces have a clean finish, with no visible warping, rough casting marks, or structural weaknesses. However, what happens inside the pump is even more critical. The internal parts such as plungers, sleeves, delivery valves, springs, and seals must be manufactured within very tight tolerances. Excessive internal play, uneven finishes, or misaligned components lead to fuel leakage, unstable pressure generation, and erratic engine performance. Upon careful evaluation, the internal components of this pump show minimal shaft play, tight fitting between moving parts, and well-machined bore surfaces. These features indicate a manufacturing process adhering closely to engineering standards. Next comes functional testing. In a laboratory or workshop setting, the pump is usually attached to a test bench where fuel delivery pressure in response to simulated engine speeds can be measured precisely. The objective is to verify that the pump maintains stable fuel pressure across the entire engine RPM range and reacts swiftly to throttle inputs. In practical use, this pump exhibits commendable pressure stability, delivering consistent fuel volume and pressure from low idle through medium and higher RPM ranges. Throttle response remains crisp without noticeable lag or hesitation. Smooth combustion without excess smoke or engine surging was observed under moderate loads. Such performance indicates that the internal precision and mechanical design are adequate to meet Perkins 1004.4D engine demands. Nevertheless, long-term reliability tests are required to fully endorse durability. Moving on to installation, replacing a fuel injection pump requires careful handling. Beyond mechanically mounting the pump onto the engine, the fuel lines must be connected properly, and the system must be bled to remove trapped air. Timing adjustment is critical to ensure fuel injection occurs exactly when required during the combustion cycle. This pump includes features that facilitate installation and calibration. The advanced mechanism and timing plate allow fine-tuning without excessive resistance or looseness. Bleeding points are positioned conveniently, allowing air to be purged efficiently from the fuel system. During a controlled installation process, bleeding was performed until no air bubbles appeared, and timing was adjusted according to engine manufacturer specifications. No abnormal resistance or misalignment was encountered, which is promising for field technicians. Durability assessment involved running the pump for extended periods under conditions simulating real operating environments. These included exposure to vibrations, temperature fluctuations, and repeated fuel pressure cycles consistent with typical excavator workloads. After many hours of operation, the pump maintained consistent pressure outputs and showed no signs of fuel leakage or mechanical degradation. Wear on internal components was minimal, and the pump continued to respond smoothly across the tested RPM range.